सो हेलो स्टूडेंट्स, स्वागत है आपका हमारे यूट्यूब चैनल पे। तो आप सभी को मेरी आवाज़ अच्छे तरीके से जा रही होगी। यदि मेरी आवाज़ अच्छे तरीके से जा रही है तो चलिए स्टार्ट करते हैं। तो आज का हमारा सेशन जो रहेगा वो है बाइनोमियल थ्योरम के बारे में। सो बाइनोमियल थ्योरम क्या है, जो हमने पिछले क्लास में कुछ डिस्कस किया था बाइनोमियल थ्योरम के बारे में। So let me start this session by sharing my screen. So I am sharing my screen. तो कल की क्लास में हम लोगों ने बाइनोमियल थ्योरम के बारे में पढ़ा था। जो बाइनोमियल थ्योरम है जिसमें कि दो एक्सप्रेशंस होते हैं, जो x प्लस वाई होल टू द पावर एनी टर्म, एनी इंटीग्रल टर्म we can find by using the binomial theorem. So this one formula, the binomial theorem formula. Once I revise again, theorem formula. If it is given x plus a whole to the power n, so it can be written as nc0 x to the power n into a to the power 0 plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 plus any general terms can be written as, that is ncr x to the power n minus 3 n minus r into a to the power r, and the last term will be the ncr ncn x to the power 0 and a to the power n. So this is the expansions of x plus a whole to the power n. So if there will be the n, if the exponent is given n, the total number of the terms in the expansion, total number of terms in the expansion, it will become n plus 1. We have seen in the previous class, that is the here we have seen in the previous class, we can see here n is equal to 2. So there are the three terms in the a plus b whole square. If the n is equal to 3, so in that case then the number of the terms will be the 4. If the exponent will be 4, so number of the terms in the expansions will be 5. Similarly, if the number of the if the exponent is 5, so number of the terms in the expansions will be n plus 1, that is the 6. In this one, there will be the number of the terms will be the 7. Okay. So in the yesterday class, we have seen about the middle term. The middle term, if the n is even, so the number of terms will be n plus 1, and n plus 1 will become odd number. So the middle term will become, it is n by 2 plus 1th term. N by 2 plus 1th term. Now, if n is equal to odd, then the number of the terms in the expansion, it will become n plus 1, that is the odd number. So there will be the two middle term. In that case, there will be the two middle term. What are the middle terms? That is the n plus 1 by 2th term and n plus 3 by 2th term. That will be our middle term. Okay, so we will see some questions based on the middle term, And we have seen also the general term in the expansion. General term in the expansion, that is TR plus 1, it is equal to NCR into x to the power n minus r into a to the power r. General term of the expansion of x plus a whole to the power n. So there is a question is given. One of the questions we are trying to solve. Okay. So the question is given, find the middle term. Find the middle term. Middle term of the expansion of the series of a by x plus bx whole to the power 12. So here we can see the n is the given, the exponent is given, n is equal to 12, that is the even. So even the total number of the terms will be n plus 1, that is the 12 plus 1, that is the 13th term. There will be the total number of the terms in the expansions will become 13 term. So which one will be the middle term? The middle term, it will become, we can easily assume the middle term, it will become n by 2 plus 1 extra. That is the 12 by 2 plus 1 means 7th term will be the middle term. So how to find the T7? T7, we can apply the formula for general term, that is the TR plus 1. So 7 can be written as 6 plus 1. So we can use the formula for general term. Here n is equal to 12. So 12 C6 into x. X is a by x whole to the power n minus r. So n minus, you can use this formula. N minus r, it is 12 minus 6, and the b term, that is the bx whole to the power 6. So we can solve this one. So 12c6, how much it will come? 12 into 11 into, then 10 into 9 into 8 into 7 divided by 6 into 5 into 4 into 3 into 2 into a to the power x, a to the power 6 divided by x to the power 6 into b to the power 6 into x to the power 6. So x to the power 6 will get cancelled, and here 5 2, it will get cancelled by 10. Then 4 3, it will get cancelled by 12, and 6 can be cancelled by, this is 4 and this is 3. So how much it will be? 33 into 4, 132, 132 into 7. 132 into 7, it will become 924, a to the power 6 and b to the power 6. This will be the middle term. So without expanding, we can find the middle term. Okay. Now we will see the next question about this one. Find the middle term. Find the middle term in the expansion of 3x minus x cube by 6 whole to the power 9. So here we can see the n is equal to given 9, that is the odd number. So if there will be the odd number, so the number of terms in the expansions, it will become n plus 1, that is the total number of the terms will be the 10th number. So there will be the two middle terms. So which term will be the middle term? In the 10th, if the numbers will be the 10th, that is the, we can easily assume that is the n plus 1, 9 plus 1 by 2th term, and 9 plus 3 by 2th term will be the middle term, that is the 5th and sixth term will be the middle term. So how to find the T5? T5 can be found by using the general formula, that is the 4 plus 1. Here n is equal to 9. So 9C4, x is 3x whole to the power 9 minus 4. And the second term, it is minus x cube by 6 divided whole to the power 4. So from here we can find 9C4. It will become, the final answer will become 189 by 8 and x to the power 17. Okay. Similarly, we can find for the T6. Then we will find T6. It will be T5 plus 1. So 9C5 and 3x whole to the power 4 and minus x cube by 6 whole to the power 5. So after solving this one, we will get the 21 by 16 x to the power 19 will be the final answer. Okay. So till now we have seen the how to find the middle term of the expansions of the series of x plus a whole to the power n. Okay. Now we will see the numerically greatest term in the expansion. Numerically greatest term in binomial expansion of x plus a whole to the power n. So which term having the greatest numerical term? Okay. So it will be the independent of the sign. Okay. So only we will see the which term having the coefficient, it will be the numerically that is the greatest term in the x plus a whole to the power n. Generally this term can be asked. So without the expansions of the series, we can find the which term having the greatest numerical term. So first of all, we will find the conditions, for which conditions it will be suitable. Okay. So since let tr plus 1 is the numerically greatest term. We have assumed the general term of the tr plus 1, it is the numerically greatest term. So we can see that, so tr plus 1 divided by tr, it should be the greater than, will be equal to 1. So we will use the formula for tr plus 1, that is the NCR and x to the power n minus r into a to the power r, and tr can be written as NCR minus 1 and x to the power n minus r plus 1 into a to the power r minus 1. We will try to solve these expressions. Okay. So NCR divided by NCR minus 1. So NCR, it will be n factorial by r factorial and n minus r factorial divided by n factorial by r minus 1 factorial, and it will be n minus r plus 1 factorial. Now we will see the second term, that is the x to the power n minus r. So it is in the division, so it will be subtract. So minus n plus r minus 1 into a to the power, that is the r minus r plus 1. It should be greater than equal to 1. So here we can see n factorial will get cancelled. R factorial can be written as r into r minus 1 factorial. So this one also will get cancelled. So in the denominators, it will become 1 by r. Okay. And here it is n minus r. So n minus r, this one will be the n minus r plus 1. So in the numerators, it will be n minus r plus 1 into n minus r factorial. N minus r factorial will get cancelled. So we can easily say this one into x to the power n cancel and r cancel. So x to the power minus 1 into a to the power r get cancelled. So a to the power 1 will be greater than equal to 1. So here we can see the NCR divided by NCR minus 1. Its formula will be, we can generally use n minus r plus 1 divided by r, and this one can be written as a by x greater than equal to 1. So while writing in this term, we can write it into the modulus term. This one, because we are finding the r term, this term will be the greatest numerical term. So the a and x, it will be the independent. The r value cannot be the negative. So that we are taking its value will be in modulus. Okay. So here we can write n plus 1 by r minus 1 in greater than equal to x by a. Okay, so r will be n plus 1 by r will be greater than equal to x by a plus 1. So from here we can say that r will be less than n plus 1 divided by x by a plus 1. This is the conditions for when r will be less than n plus 1 divided by x by a, so that we can find the r value. So if sometimes we will take plus 1, sometimes it's fractions, or maybe in the assume the right side value it is equal to k. So if k is integer, k is integers, then the tr plus 1, then there will be the two middle term, that is the tk and tk plus 1 are the greatest numerical term. Or in that case, if k is not an integer or in the fractions, so k will have the some value like m plus in the fractions. Okay, so let us say an integer, m is an integer, so its greatest term will be the tm plus 1. Tm plus 1 is the greatest numerical term. So this one conditions for the greatest numerical term, for the conditions greatest numerical term for the conditions of x plus a whole to the power n. Okay, when the expansions, the series of the expansions will be given in the form of a minus x whole to the power n. So in that case, r will be, the conditions of the r will be less than equal to n plus 1 divided by the x, and a will take its changing its position, means a by x plus 1. Okay, when we will solve by using this one, it will come in this form. Okay, so now we will see the some questions. Here it is given one question: find the numerically greatest term in the expansion of 3x plus 2 whole to the power 9, where x is equal to 3 by 2. So we can compare it by x plus a whole to the power n. So here we can say that here is the x value, it is equal to 3x, and x value here it is given 3 into 3 by 2. So its value will be, x value will become 9 by 2, and a value will be equal to 2. So what is the conditions for the greatest numerical term? That is the r will be less than equal to n plus 1 divided by x by a plus 1. So we will put the value of this one, and n is given 9 plus 1 divided by x plus a. X is given 9 by 2 divided by 2. Okay, plus 1. So how much it will be? 10 divided by 9 by 4 modulus plus 1. So we will take the LCM, that is the into 4 divided by 13. 14 by 13, that is equal to 3 how much it will be? 3 point something, 3 plus 1 by 13. So here we can see it is in the fraction. It is in the fractions, and 3, it is the integer part. It is the value for m. So here just now we have seen if the k value, this value will be equal to k, and k it is in the fraction. So we will write the fractions in the terms of the integers plus fraction. Okay, so the greatest numerical term will be the tm plus 1. So here we can write the integer term has been term 3. So t4 is the numerically greatest term. So we will find the t4. T4 can be found by 3 plus 1 by general. N is 9. 9c3x to the power. How much? That is the first one value, 3x and 2. So 3x whole to the power 9 minus 3 is 6, and 2 to the power 3. So it can be evaluated, and after the simplification, 7 into 13 to the power 3 to the power. 7 into 3 to the power 13 divided by 2. This is the greatest numerical term. Now we will see the again one more questions. Find the numerically greatest term in the expansion of here it is expansions of 3 minus 5x whole to the power 11 when x value is given 1 by 5. Okay, so now we will try to find it. So here it is in the form of x minus a minus x, a minus x whole to the power n. So here a is equal to 3, and x will be taken as the 5x, and x value is given 5 into x, that is 1 by 5. So here it will be the minus, so minus 1, x will be minus 1. So for this expressions, a minus x, for a minus x whole to the power n, our value will be less than equal to n plus 1. Just now we have seen n plus 1, and this one value a by x plus 1, modulus of a by x, modulus of a by x plus 1. So we will solve for this one. N plus 1, n is equal to, here it is given n is equal to 11. So 11 plus 1 divided by modulus of a is 3 divided by minus 1. Why we have taken in the modulus? Because we want the r value, it is will be the positive. We cannot say the like that, so that the t of the minus third term, minus second term. No, it will be always, the terms will be either the first, second, third, fourth, not like minus first term, minus fifth term. Okay, so that here we are taking in the modulus. So less than equal to 12 upon 3 plus 1, that is 4, and r will be less than equal to 3. So if this is in the integer form, so if the it will come in the integers form, so there will be the two middle term, two terms having the greatest numerical term, which term will be, that is the T3, and T4 has the greatest numerical term. So we will find the T3 is equal to NCR. N is 11C3 into x. X is how much? 3. 3 to the power 11 minus 3, 8, and minus 5x. Minus 5x to the power 3. Or we can find T4, it is 11C4, 3 to the power 7 into 5x whole to the power 4. So when we will solve these two, all we will get the, in both the case, we will get the same numerical coefficient and which are the greatest numerical coefficient, that will come 55 into 3 to the power 9. Okay. So in the today's video, we have seen the which term having the greatest numerical term without finding the expansions of the series. Okay. So here I'm stop sharing the screen. So in the today class, we have seen very important term. What will be the middle term in the expansions, and what will be the latest numerical terms in the expansions, and we can calculate it by without finding the expansions of the binomial सीरीज. ठीक है. सो आज तक के लिए बस इतना ही. तो मिलते हैं अगले क्लास में. अगले क्लास में बाइनोमियल्स थ्योरम से ही रिलेटेड नए कंसेप्ट को देखेंगे. तो अब तक हम लोगों ने बाइनोमियल थ्योरम में पढ़ चुके हैं जो है कि बाइनोमियल टर्म्स का एक्सपेंशंस, द जनरल टर्म ऑफ द एक्सपेंशंस, the middle term of the expansions, and today we have learned about the greatest numerical term coefficient. Okay, so आज के लिए बस इतना ही. तो मिलते हैं अगले क्लास में, that is tomorrow. So मैं तब तक के लिए शुभ रात्रि. Good night to all. Okay, so we will meet you tomorrow.